Hi everyone, welcome back to our channel. Today we are going to find the solution for this problem. Find the magnitude and direction of the unknown currents given I1 current is given to us, as well as I2 current is also given to us, and I5 current is also given to us. We need to find out the unknown currents I3, I4, as well as I6 and I7. So in order to do it, you can see here this comes under, you can see here this is a closed path 1 and this is another closed path. This network is called a bridge network. This is called bridge network. Why it is called network means it has a, this is one closed path, this is another closed path. That's why more than one closed path or more than one circuit, it is called as a network. That is the importance of this network. Let's try to solve. So how to find the currents is apply KCL at each node. Apply, we need to find the currents, apply Kirchhoff's current law. If you want to mark the nodes, let's try to mark it as 1, 2, 3, 4. Apply Kirchhoff's current law at node 1. So what are the entering currents? You can see here I1 is entering. Okay, so already given 10 amperes is entering, leaving is 6 plus I4. So the value of I4 is equal to 10 minus 6, which is nothing but 4 amperes. So the value of I4 is 4 amperes. We have been find. Next, this is known. We need to know this current. That's why we'll try to apply here. Okay, apply Kirchhoff's current law at node 2. So what are the entering currents? 6 amperes current is entering the node and it is leaving as I3 and I5. So it is leaving as I3 as well as I5. But 6 is equal to I3 is unknown, but in the problem I5 is given as 4 amperes. Therefore I3 is equal to 2 amperes. 6 minus 4, which is nothing but 2 amperes. Therefore the value of I3 what is 2 amperes. This is 2 amperes. So now we successfully find the values of I3 as 2 ampere, I4 as 4 amperes. Now come to this node. To this node, try to apply Kirchhoff's current law. What are the entering currents? I4 current is entering and I3 current is entering. So I can write down I3 plus I4 is entering and it is leaving as I6. So the magnitude of I3 already we had find, which is 2 amperes. The magnitude of I4 is 4 amperes, that is equal to I6. So I6 is equal to 2 plus 4, which is nothing but 6 amperes. So here the current is 6 amperes. Similarly, apply Kirchhoff's current law at node 3. So what are the entering currents? Here I5 current is entering from this branch like this and I6 is also entering. So I5 is entering as well as I6 is also entering and it is leaving as I7. I6 is how much? 4. Sorry, I5 is 4, I6 is 6, that is equal to I7. Therefore I7 is equal to 10 amperes. So the current in this branch is how much? 10 amperes. Now we successfully find the values of I6 is 6 amperes and I7 is equal to 10 amperes. So you can see here how to understand this problem is. So, and I can give a conclusion that I1 is equal to I7. Why? Because so to the network, to this bridge network, 10 amperes is entering. To the bridge network, the same current will leave, which is nothing but 10 amperes. So here you can see here 10 amperes current is entering and it is dividing as 6 amperes and 4 amperes, so it is balanced. So again here it is entering as 6 amperes and it is dividing. So this 6 is dividing as 4 amperes as well as 6 amperes. And now in this branch 4 amperes is, 4 amperes is flowing, and in this branch 2 amperes is flowing. 4 plus 2 is equal to 6 amperes. To this branch 6 amperes is flowing and 4 amperes is flowing, which get added here to result a current of I7, which is nothing but 10 amperes. So for the given bridge network, we successfully find the currents in each resistive branch. This is all about finding the directions as well as the magnitudes of unknown currents, which are I3, I4, I6 as well as I7. Hope the problem is clear, or able to understand how to find the current. So here I applied only one method, which is nothing but Kirchhoff's current law. So hope the content is useful to you. If you feel the content is useful to you, please like the video, share it with your friends, and if you have any doubts, let me know in comment section. And thank you for watching. Kindly subscribe to my channel KV Thulasi Ram. So this is a free channel for the development of students as well as for the faculty. In soon many videos will be released in our channel. So in your free time, just watch the channel, and if you're watching, if you want to support me, just give one like. And if you feel the content is useful to you and your friends, share to your friends. And if you have any doubts, let me know in comment section. I can answer you within a day maximum. Okay, so hope we'll meet in the next video.